Your magnetic circuits, I think so, right? We've already started the subject for you. So how far it is gone? You are into the second unit, right? So you know what is the basic principle of operation of a DC motor. Yes or no? Yes? How many of you know that? All of you know. Hope you all know about the basic principle of operation of your DC motor. Now let me talk about this little bit on your AC machine, your induction machine a little bit, and finally I'm going to do it to your last unit with stepper motor, right? So today you're going to see about the detailed principle of operation of your stepper motor, all that, right? Now you should know what are going to be the classical motors, right? So the classical motors, they are nothing but they produce a instantaneous torque, right, throughout and for its rotation. And it does not require any starters, right? So those are nothing but your classical motors. So the earlier versions of your classical motors are three. One is your wound field DC motor, DC commutator motor. You have your AC motor, which is going to be your induction machine or your synchronous machine. Okay? So you name the classic, you just say that the classical motors, these are the three classical motors. They are termed as classical because these motors satisfies the three important criteria. The three important criteria is that they produce essentially the instantaneous torque, okay, for its rotation. They operate from pure AC or DC or sine wave supply, and they can start and run without electronic controllers. Okay, so I am basically an electrical person. I may incline my teaching towards electrical part of it, right? And you are basically a biomedical, right? You are biomedical students. So I wish you can interrupt me at any instant of time when you feel that you don't understand anything, right? I give you the freedom, you can interrupt me at any point of time when you don't understand, okay? So the classical motors are your DC motors, AC motors. The two motors are going to be your induction motor and your synchronous motors. Okay. Now tell me what is going to be the construction of a DC motor. You have learned already. How does your DC motor look like? You will have you have a stator, the yoke or your front, which is going to support you, the mechanical part of it, which is going to give support to your machine. Inside it you find the rotating part is your armature, and the way you take these windings inside the armature can be your lap wound or your wear wound. Yes, you have learned all that. So you have the armature which is being carried out. The armature is nothing but you will have your rotor, slots and teats being cut on the outer periphery of your rotor. The armatures are nothing but the windings, electrical winding, which is being taken into this armature part of it. Okay, and you find that you will have a brushes and commutator segment. Okay, and your stator is going to have pole shoes, and you have field windings in it, right? So essentially the two basic parts of your DC motor is your field and your armature, right? So what is the basic principle of operation that is involved in the operation of your DC motor? Tell me. It is the machine which is going to convert your electrical into your mechanical rotation, right? Now electrical, I need to send current through your field winding. Yes, I need to send current through your field winding. Now what happens? What is the basic principle involved? You have learned in even your class 2. You have two magnets, this side north and this side south, and you will have a two-turn coil inside. The current is forced into the coil. You find that there will be a force which is going to act because of your flux density B, the current I and the L, BIL, right? So this is the force which is going to make it to produce your torque, right? And that's how your machine is going to rotate. Same machine can be identical. You can use that as your DC generator. A machine which is going to be of same thing. You can give an electrical input. It is the one which is going to convert it into your mechanical output. Give a mechanical input. It is going to generate you an electrical. So the same machine, identically a same machine, can be made to